Okay, here we go on to question 3, and we'll start with part A and go from there. Okay, so I'll let you pause and read this, and otherwise I'll get straight on with it. So this question is a triangular distribution, and they're asking us to calculate the probability that it'll take more than 8 minutes to embroider a logo. So here's 8 minutes. And if we're looking for the probability that it will be more than 8 minutes, then that's going to be all of this area that is larger than 8 minutes. Now that is quite an awkward shape to work out, so instead of working out that area, I'm going to work out the area of this triangle here, and then subtract the probability of 1, because that triangle is a lot easier to work out. Okay, so let's just write down something here. We'll write down that we're working out the probability that x is larger than or equal to 8, and so we're saying that that's the same as 1 minus the probability that x is smaller or equal to 8, and that probability is just going to be the area of that triangle. So a triangle is a half base times height, and our base here is 6 and our height here is 0.06, and so it's going to be a half times base times height, and we can put that into our calculator and we get 0.82, and that's our probability. Alright, so for number 2 we have a bit of a different situation. I'll let you read that as well, but otherwise I'll just get on with it. And so it found another distribution where the maximum and minimum were 2 and 22, and we've still got a triangular distribution. So I'll draw a little bit of a diagram here. So we've got 2 and then like this there up to 22, and it's saying that the ones that took less than 8 minutes to embroider, so if that was 8, all of this area adds to 0.12. Okay, so I guess one thing that we want to think about is how high it is on that scale to get an area of 0.12. And so if we label that length there x, and we think about half base times height, well, that length there is still 6. So if we say area equals a half base times height, then here our area is 0.12, and our base is 6, and our height is the unknown that we want to solve for. So it's 0.12 equals 3x, divide both sides by 3, and x equals 0.04. So that's what that height of that triangle is. Now the next part of the question is asking us to find the mode of the distribution. So the mode is the most common number, or the apex of our graph. So that's what they're asking us to look for. So because these triangles both have the same angle down here, they're actually similar triangles, and so the ratio between the sides is going to be the same. Now the other thing is up here, that maximum probability isn't going to be any different because our range is still 20. That maximum probability is going to be 0.1. And so when we're working out our triangle, our larger triangle, we know that that height is going to be x, is going to be have the same ratio with this length here. Okay, so we already know that's 0.1, and so if we go 0.1 divided by 0.04, that will give us the ratio that the triangle length has increased, and that comes to 2.5. So now we can deal with this this overall length here. Okay, so the length of the smaller one is 6, so if we times 6 by 2.25, that will, 2.5, that will give us the overall length, which is 15. And since we started at 2, we can add 2, so 15 plus 2 will give us 17, and that's going to be our mode. Okay, so mode equals 17. So all of this work here is really just with triangles and seeing if you can apply triangles to a distribution. And that's it.